All right, so today we'll talk about the object code. Let's first try to understand what does it mean, and then we'll try to figure it out. So again, remember the last class we looked at how instruction look. I mean, how does an instruction look like? So most of the instructions we have most of the instructions have two parts. So in the first part we have an opcode. The second part we have operand. There are exceptions, right? In case of inherent instructions, there is no operand. So, and then all of the instructions, if you are writing the instruction like this, are actually decoded by the assembler to just raw binary, right? Now, we write the binary in hex in our class, in our PowerPoints, in our exam, because we just want to make it compressed, but it doesn't matter how we write it. In computer, it's all digital, all binary. But if you look at here, we wrote that this is also called the object code, okay? Meaning this 8602 for that instruction is called object code. Now, how do I get this object code? Today we'll learn how we get this object code, okay? What exactly, how we find it. So this is something like the translation of the instruction that you are writing, okay? Meaning all the instructions that you are writing in the assembly program, even in the C++ or higher level language, whatever you write, at the end of the day, you get, your computer get, your microprocessor get all these instructions in binaries, okay? These are all object code. Why? Because even if you are writing in the high level language, for an example, C++, the C++ compiler also compiles it back to assembly, and then the instructions look like this one, for an example, and then it's again decoded to just raw binary. Now the one that is raw binary is called object code. So this translation actually occurs before you execute it, okay? Because at the beginning what happens, what you are writing, the compiler and assembler combined, they actually translate these to this object code. Now once you have all object codes, then your microprocessor can read it, understands, and then execute it, okay? So that means this process is even before the execution, okay? So nothing is executed, none of the code executed, it's just translation. Now, after the translation, you'll get all this code called object code, okay? Now today we'll see how we can write object code from a given instruction. And again, as I have mentioned in the last class, we do not understand the instructions yet. The only thing we can is we can identify the addressing mode. And today we'll also learn we'll probably make one more step, which is writing the object code for every instruction you can see, even if you don't understand it, okay? Let me show you a couple of steps that we follow to write the object code, and then we'll show you some examples. Step 1, which is actually the last lecture, identify the addressing mode of instruction. So if you are given an instruction and you are asked to write the object code, the first step is you have to identify the addressing mode. Now at this point we know 4 addressing mode, right? Immediate, direct, extended, and inherent. So identified. Number 2, we'll find the instruction from the set of instruction, right? Remember we have an instruction set, right? We'll then find it from the list of instruction that we have. Number 3 is, if you can recall on the, if you even can check right now on the column 4, for every instruction we are given all the possible addressing mode it can support, right? Remember last class we also checked the column 4. So from the column 4 you will have to find out what is the addressing mode it actually is supporting, right? And then step 4, write 1 byte, because we always check these, because there is one reason, because remember, even if we understand what is the addressing mode, we still need to check it, The reason is, remember there is an exception about the direct, because in some cases, even if your instructions look like direct, it's actually not direct, it's extended, right? Because the instruction, the specific instruction probably does not support the direct. So we have to double check that one. So that is actually the step 3. In the step 4, we write 1 byte of opcode of the instruction given in the column 5. So in the column 5, we are given the opcode. Opcode is nothing but just look like an hex number. Again, as I said, everything is hex when you are writing here, but it's actually raw binary. So, but you know, hex and binary are so close, you can connect it very easily. So in the column 5, for every instruction we are given a opcode. For every instruction, for every addressing mode, we are given an opcode. So we find the opcode from column 5, and the very last step, we write 1 or 2 byte of operand in hex. Remember, every instruction, most of the instruction has an operand, right? Second part. So we just write the operand in hex, okay, and put a space between the opcode and operand, okay. Now the operand can be 1 byte, operand can be 2 byte, and it depends, okay. Now let me show you an example, and then let me tell you how exactly I got that. For an example, let's say we are given this instruction, okay. Now what is the addressing mode first? What is the addressing mode of this instruction? It's probably the very last page, right? What is the addressing mode? No, I'm talking about what is the addressing mode? Direct, immediate? Is direct. It should be direct, right? But you always have to, anytime if you have something direct, you always should double check. So this is actually direct. So let me show you how exactly I'm working with this one, okay? Now let's say, you see here, this is my instruction, right? SUBB. Okay. Now I know that this is direct, right? So look at this. For the direct, we have an opcode in the next column, which is D0. Do you see it? The D0 here for direct. So that is how I actually got the opcode. And these opcodes are pretty unique. So that means for every instruction, for every addressing mode, we have almost a unique opcode. So the opcode we got from here, which is D0, and then if you go to the column 6, you see there is something written here, which is, let's say for an example, in this case it's written DD. Now DD doesn't make any sense. The only thing it actually tells you that the object code, I'm saying the opcode following the operand, the operand will be just 1 byte. That's what I'm saying. It actually tells, meaning the column 6 actually tells you how long will be your operand, meaning how long it will be. So for an example, if it is DD, means it will be 2 hex digit. That's what I'm saying. 2 hex digits means what? 1 byte, right? If it, I'm saying, as I said, operand can be either 1 byte or 2 byte. Okay. Now if you see 2 hex digit, it's 1 byte. If you see 4 hex digit, now see in this column, sometimes you'll see I, H, F, D. I'm saying that doesn't make any sense. That actually only tells you the length. Okay. Now since it is DD, that means there will be 2 hex digits. So that means you have to write the operand in 1 byte. Okay. Now let's go back and see what we have here. Let's go back. So remember, we got an opcode and we got an operand, right? Now see, this is how exactly I got it. So we got the opcode. Remember, we got the opcode from the list, which was D0, right? And how do I get these? This is the operand, right? Okay, what is my operand in the original instruction? No, I'm talking about here, 35, right? My operand is 35. But can you recognize what is, I'm saying, how the 35 is written? What is the number system? Is this decimal? This is decimal, right? Now remember, anytime we have it in any number system, we always convert it back to hex. So we actually converted 35 into hex. So that means no matter how the operand is given, because you can be given, I'm saying your operand can be given to you as hex, as binary, or as decimal, right? You always will convert it to hex. I'm saying if it is in hex, you're fine, but otherwise you convert it. So the 35 is binary, I'm saying decimal, I'm sorry, the decimal, so we convert it back to hex, which is 23. And again, we wrote 23 in 1 byte because it was mentioned on the column 6 that you have to write it 1 byte. You might be wondering, how can I write 23 in 2 byte? Because you can always plug additional zeros, right, in front to make something 2 byte. So if you have to. Now, let's look at our next example. Here is my next one. What is the addressing mode? That's always will be the first question, because if you don't know the addressing mode, you cannot find it in the column 5, you cannot use column 6. That's inherent, right? That's probably the easiest one. Inherent, right? Because it doesn't have any operand. Now if I go back to my instruction set here, if I go back to my instruction set and let's find the ABA, that's probably the very first page, right? Yeah, the very first one, right? So if you look at here, ABA, that only has one addressing, I'm saying that only supports one addressing mode, inherent. And what is the opcode here? 1B, right? 1B. Now, look at the operand column. There is a hyphen here because there is no operand. I'm saying there is no operand you need to write. So basically the answer is very simple. So the answer is very simple. All you have to do write is only the opcode. It's just 1 byte because there is no operand. Okay? Any question here? Okay, let's look at the next example. What is the addressing mode? How it is immediate? I'm saying there is no pound sign, right? That's a dollar sign. That's extended, right? This if you don't see pound sign, it cannot be immediate, right? So this is extended. Because if you see here, there is no pound sign, first of all. And second is the operand is more than 1 byte, right? It's more than 1 byte long. So that looks like 2 byte. So basically this is extended. Now let's go back and see how do I know the object code of this one, okay? The instruction is std, right? Let me type std here. Now here is my std. So this is extended, right? Yeah. Now my opcode is what? FD, right? Do you see the opcode? Let me make it a little bit bigger. And then how long will be my operand? Do you see the operand? Operand is like 2 byte this time, right? Because this actually tells the length of the operand. So now let's go back here and write it down. So this is how I write it. Because the first byte is for operand, first byte for the opcode, right? This is the opcode we got from the list. And second byte and third byte are the operand byte. Now remember, when we write the object code, we always put a space between the bytes, just to let everybody know that okay, we are writing different bytes, because this object code is 3 byte long. So we just wrote first byte and then second byte and then again a space third byte. Okay, but remember the second byte and third byte, both of the bytes are actually operand, right? Both of those bytes are operand. Only the first byte is your opcode. The opcode is always 1 byte. Okay, and we got it from the column, column 5. It will be always 1 byte. Any question here? Let's look at the next one. Again, what is the instruction mode? I'm saying that what is the addressing mode? Extended, right? Now let's go back to our instruction set. If it is extended, let's find it first. Here is my STX extended, so the opcode is FF, right? And how long will be the operand? 2 byte, right? So you have to write the operand in 2 byte. How did I write it? Now this one is my opcode, right? FF is my opcode. Now how do I write this? Because the number you're given is in decimal, right? Yes. Remember, you always convert it to hex. So I converted 256 into hex, which becomes 100, but I have to write it in bytes. Even if you got 100, you have to write like 0100 because you have to make it like 2 byte. And again, this is interesting because this is exactly how your instruction is written in memory, okay? Because this translation is done before even if any instruction is executed. Meaning whenever you are writing the instruction, this instruction, for an example, is actually translated and is written in 3 bytes. And then your microprocessor will read it in binary, and it will understand exactly what you are telling. Okay. Any question? Okay, let's try another one. What is the addressing mode? That's probably the easiest, right? You have the pound sign, so you know for sure this is immediate. Now let's find it. This is probably on the first page. Oops. Okay. Now this is my DDD and this is immediate. So I got my, this is C3, right? Yeah. Now how long is the operand? 2 byte. So you know it from there, it's 2 byte. Let's check the answer. We wrote C3 and then we wrote the operand in 2 byte. But before that we converted the operand, right, from decimal to hex. So you always have to make sure that you see the number system you are given, because the number you have here, 3512, is in decimal, right? Because there is no dollar sign, there is no percentage sign in front of the number, right? So that means the number is decimal and you are converting it. Any question? All right, let's try another one. NEG 29. Let's go back to the, is actually extended because I think that this instruction does not support direct mode. So if you go here, this is extended, right? Yes. This is extended, and how long would be the operand? 2 bytes. So basically, if column 6 tells you that the operand will have to be 2 byte, you have to write it in 2 byte, no matter how it is given, okay? So this is how we write it. See, the first byte is here for, this is the operand, right? 70. I'm saying this is the opcode, right? 70, and we got it from column 5. And then we converted 29 into hex, which is 1D, but we have to write it in 2 byte, right? Remember? It was told in column 6 the operand will be 2 byte for sure. So no matter how the operand is given to you, you have to make it 2 byte. To make it 2 byte, we plug some zeros in front, right? I'm saying, so if you plug in front of the operand some zeros, the operand doesn't change. So, but its length changes, but its value doesn't change. So we made it 001D to make it 2 byte. Okay. Any question? So again, object code is really important to understand, because if we understand the object code, you'll have a better idea exactly how the microprocessor reads the instruction. Okay, so microprocessor basically reads the object code, nothing else, because no matter how we are writing, meaning you are writing in high-level language, you might be writing in assembly, low-level language. At the end of the day, all the instructions are actually translated into object code. Probably not in hex, in binary, but we are writing in hex here so that we can see it in compressed mode. But even if it is in hex, microprocessor just read that one, okay? And microprocessor knows exactly what you are telling based on the opcode. Because as you have seen that we have opcodes for every instruction, for every addressing mode, we have a unique opcode. So you can think it just like a code, and if microprocessor read the code, microprocessor knows you are actually writing NEG. That's what I'm saying. Because microprocessor cannot read NEG, it reads 70, then it knows that you are actually trying to tell NEG. And then it knows that since you wrote NEG, the next 2 byte will be the operand. Because think about this, have you ever thought that how the microprocessor knows which one is the instruction and which one is opcode and which is even your operand? Because all looks like same, right? Because all are binaries. This is how microprocessor knows it. For an example, when the microprocessor reads 70, it knows that you are writing NEG, and then it also knows that the next 2 byte will be your operand. Because all bytes are in binary. I'm saying if you are given like a bunch of ones and zeros, it's hard to tell, okay, which one is my opcode and which one is my operand, because it's all look like same, right? But you know, just from here, microprocessor knows it very well and it does it very, very correctly, okay? So let's try our next quiz, which is quiz 2. In each question, you'll be given an instruction, and for every instruction, you have to write an object code. But be careful, some of the object codes are 1 byte, sometimes it's 2 byte, sometimes it's 3 byte, and operand is always written in hex. If it is not in hex, convert it to hex, okay? Any question? Okay, let's go to the quiz section and let's try the quiz 2.